Hello again, this is Mr. Scheider, and here is your Lesson 2 notes for the second half, where we look at negative velocities. So starting with our description of motion again, our next possible motion is a fast, constant, negative velocity. The way that looks on your position versus time graph is like this, with a steep line indicating fast. The slope is negative, indicating that the velocity is negative, and it's linear. It's a straight line, so that tells us the velocity is constant because a linear graph has a constant slope, and slope is velocity. Okay, the way that would look on a motion diagram, since this is the positive direction, is like this. The dots need to be far apart because it's fast. They need to be the same distance apart because it's a constant velocity. And the arrows need to be pointing in the negative direction because it's a negative velocity. Okay? Then, just like last time, we take the arrows and we stack them up over here on the v versus t graph, except now, because the arrows are pointing to the left, they go down from 0. So I take my first arrow, I put it right there facing down, because this is where the negative velocities are, and these are pointing in the negative direction. I take my next one, again I put it down, and I take the last one and line it up like that. Then I connect my points at the top. Okay, so that's what my v versus t graph looks like. I get a horizontal line at a negative value. And just to put some numbers on here, this is definitely 0, and let's just call this negative 10. And we're going to assume this is measured in meters per second. Okay? So if I was looking at my motion diagram and I wanted to put some numbers on it, this could be, let's say this is 30 meters, this is 20 meters, this is 10 meters, and this is 0 meters. So notice that each arrow travels 10 meters to the left, and each arrow, the time interval is 1 second. So it goes 10 meters in 1 second to the left. In other words, it goes negative 10 meters per second, which is why you have this velocity versus time graph that's at a constant value of negative 10 meters per second. So the thing that's constant about this graph is the value that it's at, negative 10 meters per second. The thing that's constant about this graph is the slope. It goes down and over the same amount every second. Okay, last one. Last possibility is a slow, constant, negative velocity. That would look something like this. Okay? So it's slow. It's not very steep. It's constant. It's a linear graph. In other words, a straight line. It's negative, so the slope is negative. It's pointing down. And yeah, that's it. Okay, so then the motion diagram would look like this. Again, this is the positive direction. Because it is slow, my dots need to be close together. Okay. The arrows are the same length, and the distance between the dots is the same length because it's moving with a constant velocity. Okay. And then the arrows are pointing to the left because it is negative. So now I take this and I translate it to here. So I take my arrows, they're pointing to the left, so I stack them up like this, and they have to point down. There we go. I've taken my arrows from my motion diagram and lined them up on the graph. And then I connect the points with the horizontal line. Okay, and that's what my velocity versus time graph would look like. Now, you might notice that these seem like they're about the same length as these, and that I've drawn the length of the arrows over here slightly differently. So I wasn't perfect. That's okay. The big idea is qualitatively, these arrows are short because this is slow, and these arrows are longer, and as are these are also longer, even though they're not the same length as these, because they're fast. So first of all, this is just qualitative. So if you notice that discrepancy, it's okay. All right, so let's put some numbers on here as the last thing. This is definitely 0. And let's say maybe this is, well, if this is 0 and that's 10, this would have to be 6. Okay, and then this is meters per second. So if I want to put some numbers over here, I could say that this is, 18 meters. This is 12 meters. This is 6 meters. And then this would be 0 meters. So each arrow shows some object is traveling 6 meters to the left. That's 6 meters per second because the time interval here is 1 second. And since it's to the left, it's -6. That should be a -6. All right, thank you for watching your notes. And go ahead and do the practice page.